Welcome to another Back of the Net video. This is to help you with sequences and in particular finding the nth term. Here are some patterns made from sticks. Pattern number 1, pattern number 2, pattern number 3. In the space below, draw pattern number 4. I'm just going to draw it up here because I squashed the exam question in to make room for us to be able to draw things. So I'm now going to try and neatly draw the shape that I know will make the fourth pattern, and there it is. I'm now also going to write down the number of matchsticks used in each of the patterns. This will help me tremendously in a minute. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Now, that's actually quite helpful for me there because I've realised that in doing that I actually made a mistake, and these lines should not have been drawn in. So I don't want this line, I don't want that line, and I don't want that line. Just remembering a lesson I've taught recently, and I've made a mistake there, but I've corrected it now. Okay, how many sticks are used in pattern number 5? Now I could draw that out, but it would take a bit of time in the exam. What I should be able to see though is that these numbers here, I'm going to choose a slightly different colour pen so it doesn't dominate too much, they're going up in 4s. So the fifth pattern is going to be another 4, which would be 21. So I can just write down here 21. Now I could carry on with that idea to get pattern number 10. However, I'm just going to read the second bit here. It says find an expression in terms of n for the number of sticks used in pattern number n. Well, this is something called finding the nth term. And when it says an expression in terms of n, that is code for finding the nth term. In some questions it will actually say find the nth term, and we need to know that either seeing it like that, find the nth term, or an expression in terms of n means the same thing, in this case finding the nth term. We've done lots of work in school on this. It's going up in 4s, so it must be just like my 4 times table. So I'm going to write 4n. But I also know that my 4 times table goes 4, 8, 12, 16. And the patterns I've got, the 5, 9, 13, 17, has been shifted up by 1. The 2 times table shifted up 1, so it's 4n plus 1. Very easy question done. That is actually ranked as a grade C topic, so it's quite a hard mark to get, but straightforward. Now I've got to be careful here because I actually jumped out a question. It asked me to find pattern number 10. The reason I jumped out was I can now use my rule, my formula if you like, my expression, to get the total number of matches for pattern number 10. If n is 10, 4 times 10 is 40, add the 1, 41. Job done. Okay, so we draw the patterns. We drew the pattern out as asked. I made a mistake, but I've corrected myself. We then wrote the numbers in for the number of patterns. That helped us see what it was going up in. When I saw it was going up in 4, I knew that the pattern was to do for the 4 times table, so I wrote down 4n. I then worked out how my number pattern, 5, 9, 13, 17, 21, had been shifted from the 4 times table pattern, 4, 8, 12, 16, and it was obviously it had gone up 1, so I add 1 to it. Okay, similar question for you. I'd like to have a go at that. Press pause. Okay, welcome back. Looking at this whole question here, just this bit here gives me a real clue that this is going to be the number pattern question, because I've got things to draw out. Table here with number sticks, pattern number to fill in. I've not actually done this question before, so let's see how it goes. Okay, the first even number is 2. Write down the third even number. Well, that's knowing a bit of knowledge that even numbers are numbers in the 2 times table, so it might just be sensible for me to write at the start of my 2 times table 2, 4, 6, 8 and so on. They want to write down the third even number. 1, 2, 3, it is 6. Very simple to do. Whenever in an exam it says write down, it's nearly always quite straightforward. There's not much work to be doing. Here are some patterns made from sticks. Pattern number 1, number 2, number 3 and number 4 is down here. I don't like it actually when the fourth one is down here. I like it when it's all in one long row because it helps with my number pattern. Right, complete pattern number 4. Well, they've started pattern number 4. It looks exactly the same as pattern number 3, so all I've got to do is add that on. And now it's saying complete the table. I've noticed here that it's going up in 3s. So I'm just going to go up in 3s. There we go. Next bit. Jenny wants to find the number of sticks in pattern number 100. Write down a method she could use. Well, it's going up in 3s, so it's going to be our 3 times table, which is 3n, and actually it really is our 3 times table. 3, 6, 9, 12, 15. There's no shift required this time, so it's just 3n. And if n is 100, 3n will be 300. So she could use her method, write down a method she could use. 3n is the nth term. When n equals 100, it will be 300 sticks. And that will do for a method. Okay, another question for you. Hopefully you've now seen the pattern coming along. Have a go yourselves. Press pause. Welcome back. Here are some patterns made from sticks. Pattern number 1, pattern number 2, pattern number 3. In the space below, draw pattern number 4. I will draw it below this time because I haven't got any room to draw it anywhere else. So it seems to me to be a triangle. Then add that other triangle on. So that's pattern number 3. So pattern number 4 would be like that. It's beginning to tell me here already how many there are in each pattern. It's got 3, 5, 7. And in my first example, I was actually writing those over the top of the pictures. So 3, 5, 1, 2, 3, 4, 5, 6, 7. And this should be 1, 2, 3, 4, 5, 6, 7, 8, 9. I can now fill in a 9 in the table. And I should now see the pattern is going up in 2s, so that one will be 11. And again, a similar question. Ben wants to find the number of sticks in pattern 100. How many... Sorry, I've missed a question now. How many sticks are there in pattern number 12? Well, it's the same technique as how many in pattern number 100. So I would miss these two out. I'd find the nth term, as I've shown you how to do. Nth term, well, it's going up in 2s. So my rule is going to be 2n. The 2 times table goes 2, 4, 6, 8, 10. The pattern I've got of sticks is my 2 times table but shifted at 1. So it's 2n plus 1. Now I can go back and do this. How many sticks are in pattern number 12? Well, 12 times 2 is 24. 24 add 1, 25. Write down a method he could use for finding the number in 100. The nth term is 2n plus 1. So pattern 100 will be, well, 100 times 2 is 200, add the 1, 201. Okay, some more examples here of finding the nth term, but this is when we don't have all those patterns at the beginning to help us out and see what we're doing. So first of all, write down the next two terms of the sequence. Well, I've got to try and work out what's going on. I always look for the difference. 3, 3, 3, 3. I'm just going to write underneath there for you. Add 3, add 3, add 3, add 3. So do the next two terms. Add 3 is going to be 20. Add another 3 is going to be 23. Find in terms of, sorry, actually I ought to write 20 and 23 in there to be clear. Now, find in terms of n an expression for the nth term of this sequence. We know it's going up in 3s, so it'll be 3n. I've now got to get that shift factor. The 3 times table will be 3, 6, 9, 12, etc. And like I can see, it's just been shifted up 2, so it's 3n plus 2. That's probably 3 marks in the exam, maybe even 4. I can't decide. They'll probably just give you 1 for both of those, and then 2 for that. If you get them on a good day, you'd have got 2, 1 each for that, and then 2 for that as well, and giving you a total of 4. Fairly straightforward question. Okay, I'm going to let you go for this one by yourselves. Press pause. Okay, again, here we have. Here are the first 5 terms of an arithmetic sequence. Don't let the arithmetic fool you, just see the number pattern for what it is. It's written out for you here. Don't get fooled by the complicated language there. Work out what it's going up in. That's add 4, that's add 4, that's add 4, and add 4 again. So it's going up in 4, so it's related to the 4 times table, so it's 4n. My 4 times table would give me, just going to go with that in black so it's a bit easier for you to see on your screen. My 4 times table will give me normally 4, 8, 12, and in this case we see we've got 2, 6, 10, so it's been shifted down 2, so we write minus 2. So the nth term is 4n minus 2. That would normally be 2 marks. Hopefully you've got those. Part B, an expression for the nth term of another sequence is 10 minus n squared. Find the third term of this sequence. Well, this is really a substitution question because we know n is 3, so it's going to be 10 minus 3 squared because n is 3. Well, 3 squared is 9, so it's 10 subtract 9, which is 1. Done. Okay, those are all the questions I have for you on finding the nth term and sequences. Hope it's been helpful, and I hope you come back to watch another Back of the Net video.